Hey everyone, and welcome. So let's just dive right in. Have you ever stopped to think about how a computer actually thinks? I mean, how does this incredibly complex machine handle something as simple as a number, a single letter, or just a plain old yes or no? Well, today, we're going to open up the essential toolbox that every single Java programmer needs to understand to answer that exact question. We're talking about Java's primitive types. It all boils down to this one simple question, right? Before we can even dream of building huge, complex applications, we have to get the basics right. We need a way to tell the computer, hey, this little piece of information I'm giving you, it's a whole number. Or, pay attention, this one is just a single character. And that is the exact problem that primitive types were created to solve. And here's our answer. Primitive types. The best way to think about them is like a starter toolkit for your data. There are exactly 8 of them, and they are the simplest, most no-frills way to store one piece of information directly in the computer's memory. They're not fancy, they're the fundamental atoms of data in Java. Okay, so let's pop open this toolbox. The first couple of tools we're going to look at are highly specialized. They don't mess with numbers, they have very specific, unique jobs to do. Let's meet them. So on one side, you've got Boolean. Its entire world is just 2 simple ideas, true or false. That's it. This little guy is the foundation for every single decision your program ever makes. Then you've got char, which, as the name suggests, holds just one single character. But here's the cool part. Char uses something called Unicode. That means it's not just for $, or $sign, it can represent characters from languages all across the globe. So you have 2 simple tools, but with really powerful, specific jobs. All right, let's move on to the real workhorses of our toolbox, the integers. These guys are all about storing whole numbers, no decimals allowed here. Now, we've got 4 different tools for this, and the big question you always need to ask yourself is, how big of a number are we talking about? It's all about size. We start with the little one, byte, which can handle numbers from -128 up to 127. Short gives you a little more breathing room, but honestly, the go-to for most everyday tasks is int, which can handle numbers all the way up to about 2.1 billion. And then, for those absolutely massive values, you've got long, which goes up to, well, around 9 quintillion. You see the pattern, right? As the size in bits doubles, the range of numbers it can hold just explodes. And that brings us to a really important point. Okay, so you've got 4 tools that basically do the same job. How in the world do you pick the right one? Well, it all comes down to being efficient and choosing a container that's just the right size for what you need. Let's make this super practical. Imagine you need to store someone's age. You're probably not going to need a number bigger than 127, right? So a byte is perfect. It's small, it's efficient, it gets the job done without wasting memory. But what if you're storing the population of a city? A byte is not going to cut it. You're going to need the much bigger capacity of an int. See? It's all about matching the tool to the scale of the job. So what happens when even an int isn't big enough? I mean, the world's population is already over 8 billion people. That's way too big for a standard int. For that kind of number, or for tracking things on a scientific or, astronomical scale, you've got to bring out the big gun, the long. It is designed specifically for those truly enormous numbers. And hey, here's a quick pro tip for you. When you're typing out these gigantic numbers in your code, they can get really hard to read, fast. Well, Java actually lets you use underscores inside your numbers to break them up, kind of like you'd use commas. The computer totally ignores them, but it makes your code so much easier for another human, or, future you, to read. Okay, so we've totally nailed whole numbers. But what about all the other numbers, the ones with decimal points, like pi, 3.14? For that, we need to grab the last 2 tools from our kit, the precision instruments. These are what we call floating point numbers, and you've got 2 choices, float and double. The key difference here is all about precision. A double uses twice the memory, 64 bits, to store its value, which makes it way, way more accurate. So here's the bottom line. Unless you are working on something where every single bit of memory counts, just use double. It's the standard, default choice for a reason. And what's just mind-blowing about float and double is the sheer range of numbers they can represent. They're built on this universal standard called IEEE 754, which basically gives them the power to handle everything from measuring something subatomic and incredibly small, all the way up to distances between galaxies. It's an amazing system. So there you have it. That's the whole shebang, all 8 essential tools in your Java primitive type toolbox. We've met the specialists, we've organized the integer family, and we've calibrated the decimal duo. Let's wrap this all up into a super simple guide. This right here is your ultimate cheat sheet. Seriously. The next time you need to store a piece of data, just run through this little checklist. Is it a true-false kind of thing? Boolean. Is it just one character? That's a char. Is it a whole number? Find the smallest container that fits your needs, but you'll probably start with int. And finally, if it's got a decimal point, your go-to is almost always going to be double. It really is that simple. So now you get it. You understand the 8 fundamental building blocks of data in Java. These are the atoms. But what happens when you need to represent something more complex than just a single number or single character? What about a whole word or sentence or even just your name? Well, that requires us to start putting these atoms together. And that takes us beyond primitives into the next level of our Java toolbox.